Hello my clients, welcome to my new YouTube channel Maths for My Clients by MKV. So please subscribe and press the bell icon so that you can get all my updates. So now children, I am going to start my today's topic, real numbers. So the name of the chapter is real numbers. So what are the real numbers? As the name of the chapter is real numbers, you should understand what are the real numbers. So real numbers you can divide into two parts. First is rational numbers. Second one is irrational numbers. So rational numbers, what are the rational numbers? All the numbers which can be written in the form of P upon Q, where Q, that is the denominator, is not equal to 0. Here P and Q are the co-prime numbers. Now other real numbers are terminating decimal numbers, for example 1.45. Next, some other recurring or repeating rational numbers are there. These are, for example, 1.414141 dot dot dot. This we can write 1.41 bar. So this is about rational numbers. Now irrational numbers. Those numbers which cannot be written in the form of P upon Q, they are called irrational numbers. These are non-terminating and non-recurring numbers. For example, 1.01001 dot dot dot. So in this case, 1 times 0, then after 1, 2 times 0. Now other rational numbers are square root 3, 5 plus 2 under root 3, comma pi, etc. Now in this chapter you will learn about three topics. First one is algorithm, second one is lemma, third one is Euclid division lemma. So what are the algorithms? Algorithm means the step-by-step procedure to solve a problem. What is lemma? Lemma are some proven statements which we can utilize to prove some other results. Now Euclid division lemma. So if we say for integers a and b, where a is greater than b, there exist q and r which satisfy the relation a is equal to bq plus r, where r is greater than equal to 0 and r will be less than b. So if in this case, if we divide a by b, then we will get one quotient q and we will get the remainder r. And as we have already learnt in the previous classes, the dividend is equal to divisor into quotient plus remainder. So dividend is equal to divisor into quotient plus remainder. If we use this, we will get a is equal to b into q plus r. So this Euclid division lemma normally we are using to find SCF of two given numbers, out of which one number is bigger than the other number. In this case, we can find the SCF of three numbers, but there we cannot use this theorem. Now children, you see one problem. Find the SCF of 135 and 225. So in previous classes, we were finding the SCF by using the long division method. So in this case, 225 is bigger than 135. So we will take 225 as A and 135 as B. So in this case, if we use the long division method, if you will divide 225 by 135, it will go one time and we will get the remainder 90. Now by this remainder, we will divide the divisor 135. It will go one time and we will get the remainder 45. Now we will divide the divisor 90 by 45, so it will go two times and we will get the remainder 0. So here whenever we are getting the remainder 0, that time the divisor is called the SCF of those two given numbers. So this we will use to show this, we will use Euclid division lemma. So according to Euclid division lemma, A is equal to BQ plus R, where R is greater than equal to 0 and less than b and less than b. So now here big number is 225, so that is a, and small number is b, its value is 135. So when we will divide 225 by 135, it will go one time, so we can write 225 is equal to 135 into 1 plus 90. Now we will divide the divisor 135 by this remainder 90, so it will go one time and we will get the remainder 45. Now we will divide 90 by 45, it will go two times and we will get the remainder 0. So this process we will continue till we are getting the remainder 0, and whenever we are getting the remainder 0, that time the divisor will be the SCF. So in this case the divisor is 45, so SCF of two numbers 225 and 135 will be 45. Now let us see some other problems. See the next problem. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5 where q is some number. So children, to solve this, to show this, we will use Euclid division lemma. So according to Euclid division lemma, a is equal to bq plus r, where r is greater than equal to 0 and less than b. So in this case, if we are taking b is equal to 6, and if a is a positive integer, then a will be equal to 6q plus r. Here the value of r will be greater than or equal to 0 and it will be less than 6. So here the possible values of r will be either 0 or 1 or 2 or 3 or 4 or 5. So because these are the remainder values, so we will get first integer 6q plus 0 where r is equal to 0. Second, a is equal to 6q plus 1, a is equal to 6q plus 2, a is equal to 6q plus 3, a is equal to 6q plus 4, a is equal to 6q plus 5, because the possible remainders are 0 to 5. Now you see the first one, a is equal to 6q. This we can write 6q, we can break 2 into 3q. So it is a multiple of 2, so it will be an even number. Now you see the second case. Here a is equal to 6q plus 1. Here 6q is the even number. In this, if we are adding 1, it will become odd number. So 6q plus 1 is an odd number. Now next is 6q plus 2. Here we can take 2 common. We will get 2 into in the bracket 3q plus 1. So in this case, it is also a multiple of 2. So it is also an even number. Now you see the next case, 6q plus 3. Here 6q is odd number and 6q is even number and 3 is odd number. So even number plus odd number will become odd. So 6q plus 3 is an odd number. Now next is 6q plus 4. Here we can take 2 common. So 2 into in the bracket 3q plus 2. It is a multiple of 2. So therefore it is also an even number. Now next is a is equal to 6q plus 5. 6q is an even number. If we are adding 5, it will become odd. So this shows that any positive odd integer can be of the form of 6q plus 3, 6q plus 1, 6q plus 3 and 6q plus 5. I feel you all are understanding these problems carefully. If there is any problem, you can send this problem to me through WhatsApp so that I can give you the answer again. Now you see some other problems from this topic. Now the question is, use Euclid division lemma. Show that the square of any positive integer is either of the form of 3m or 3m plus 1 for some integer m. So as we know, by Euclid division lemma, a is equal to bq plus r, where r is greater than equal to 0 and r is less than b. So in this case, we will take a is any positive integer and b is equal to 3. So in this case, because r is always less than b, so value of r will be less than 3, and possible values of r which are less than 3 are 0, 1, 2. Now if we will put these values in Euclid division lemma, we will get a is equal to 3q plus 0. Second case, if we are putting 1, then a is equal to 3q plus 1. If we are putting r is equal to 2, we will get a is equal to 3q plus 2. So we will get 3 possibilities. Now, according to the question, they are saying to show the square of any positive integer. So these are the positive integers and we have to find out its square. Now in first case, if we are finding the square of the first equation in both the sides, in left side we will get a square, right side we will get 3q whole square. 3q whole square will be equal to 9q square, and this we can break. We can write 3 into 3q square, and 3 into 3q square we can write as m. So this will become 3m. So it is 3m multiple of 3. Here value of m is 3q square. Now second case, if we will do the square of second equation, left side we will get a square, right side 3q plus 1 whole square. Here we will apply the formula a plus b whole square and we will get 9q square plus 6q plus 1. Now from first two terms we can take 3 common, and the quantity written in the bracket we are writing it as m. So we will get 3m plus 1. So now it is of the form 3m plus 1. So where m will be equal